Okay, so today, which was 8-4, we worked on symmetry. So we talked about x-axis symmetry, right? So the picture's a little cut off here, but say this was an xy coordinate plane. This is our x and y axes. So if we have x-axis symmetry, that means that our function here, this line right here, I'll color it, is the same below our x-axis. So think of our x-axis as a mirror, and it is making our function symmetric. If this is our function on our y-axis symmetry, our y-axis is the mirror, and it is flipping this function symmetrically. Origin symmetry, right? This is the origin of our xy coordinate plane. So origin symmetry means that our function, this right here, is being flipped across the origin symmetrically. Okay, so our origin is the mirror. So here we're going to have x, y coordinates and x negative y coordinates. So this coordinate right here, AB, flipped across the x-axis becomes a negative b. Here we're going to have negative x comma y and x comma y. Write that either way. So we have this xy coordinate or AB coordinate flipped over the y-axis makes our x value negative. Okay, origin symmetry makes them both negative. So we have xy flipped over the origin goes to negative x, negative y. So you can pause this if you want to read this. This is also in your guys' book. I pulled this from the book. It's just a good explanation of how we're going to test for symmetry. Okay, so you don't have to pause it, I'll just read it. The graph of an equation is symmetric with respect to the x-axis, this first example right here, when replacing y with negative y. Right here, y became negative. Okay, the graph of an equation is symmetric with respect to the y-axis. The second example here, when we replaced x with negative x, right? X became negative, and symmetric with respect to the origin when we replace x with negative x and y with negative y. So to solve for x-axis symmetry, we're going to follow 3 steps. We're going to sub negative y for y. Okay, so we're going to make y negative. Secondly, we are going to simplify our equation, our function, and then we are going to, this is the important one, check if our function that we just yielded after subbing negative y for y and simplifying is the same as our original function. Okay, so here's an example. We started with y equals x squared plus 2. We switched negative y for y, so we made y negative. Simplifying it, there's nothing to simplify here, right? Negative y equaling y squared plus 2 is simplified. So is our original equation, our equation 1, the same as equation 2? Same? No. So they are not, there is no x-axis symmetry. Okay, if these y's were both positive, then we would have x-axis symmetry, but since they are not, we do not. So to determine if we have y-axis symmetry, we're going to pretty much do the same thing, okay? We are going to replace x with negative x, so make x negative. We are going to simplify, and we are going to check if they are the same. Okay, so looking at this example right here, our first step is to make x negative. Okay, so we're just replacing x with negative x and leaving the rest of the equation the same. Then we are going to simplify it. Okay, so nothing has to be simplified with y. Negative times a negative squared is equal to a positive. So negative x squared is equal to x squared plus 2. We can't simplify this anymore. So we want to check if our original function is the same as our function after we subbed negative y for y. So are these the same? Yes, right? They are the same. So we have y-axis symmetry. Okay. Now to determine if we have origin symmetry, we're going to do the same thing, but we're subbing negative x for x and negative y for y. So we are just making them both negative. Then we're going to simplify and check if the same. Okay. So looking at this equation right here, we want to sub negative y in for y, so make y negative, and we want to make x negative. Negative y stays the same. Once again, negative x squared becomes positive x squared plus 2. There's nothing else to simplify here, so are these the same? At first you might think, yeah, maybe, like the right hand side's the same, but we have this negative y, and that is not the same. So there is no origin symmetry with this.